Okay, so this is matrix inversion, and so we are talking about the learning activity 1 to 4 according to the subject of this section about the matrix inversion. Okay, so what it is? What is it? Is matrix inversion is about finding inverse of a matrix, and it is a unary operation uh, like matrix transposition. So in inversion, we are looking for inverse of a matrix like A power -1. It is most of the time written as a power -1. This is a unary operation. It is a unary operation as a matrix transposition, as I have said, because it is applied to only one matrix, as opposed to binary operation. This is unary operations. Unary operations. So either transpose or inversion. So it is as opposed to binary operation. Binary operations like addition, subtraction, multiplication. We have one matrix here, another matrix here. Now the product. So the multiplication, most of the time it is not written. Probably in order not to confuse it with the letter X, because it is written the same way. All those addition, subtraction, multiplication are binary operations because they are applied to two matrices A and B, but transposition as well as inversion are a unary operation, unary as opposed to binary operation. So, all right, now we're gonna be talking now about this activity. Which is learning activity 1.2.4. So, what is it? So, consider two matrices A 1, 0, 2, 0, 1, -3, 1, -1, 0, and the matrix B 1 over 5 scalar multiplication with the matrix this matrix, first row 3, 2, 2, second row 3, 2, -3, third row 1, -1, -1. Now, here we have different questions in regard with these two matrices. Find the product AB and write down its size and order. B. Describe entries of the product. This product A times B. If such a matrix, the product is called if such matrix is named or is called identity matrix, which of the following matrices are identity matrices? So we have this one, 1, 1, 1, 1, next one, third 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 0, 1, 1, 0. So sub-question D, matrix B is said to be inverse of matrix A. Okay, now when do we say that a matrix is inverse of another matrix. So suppose B. Okay. Now this is the activity. Okay, so if you are watching this video, you can pause, you can stop it now, and just find out answers to these questions. And now, I hope you did it. And now next we are going to answer this, find out the answer to this learning activity 1.2.4. Okay, this is what we are looking for. So we have two matrices, we have A and B. Now find the product. We want to find the product and write the size and order. Okay, so now here we have to answer some question. Okay, so we want the product A times B. So this is let us write down 1 0 2 0 1 negative 3 1 negative 1 0. So times 1 fifth 1 fifth times 3 3 1 2 2 negative 1 and then 2 negative 3 negative 1. Okay, so because this is a scalar, so it can be just in front. But before we do so, let us see size of these matrices and find out if the product is possible. So we have this is 3 by 3 matrix, and obviously this is scalar multiplication will also be 3 by 3 matrix. Okay, now in this case, as the number of columns of the first matrix is equal to number of rows of the second matrix, so the product will be also a 3 by 3 matrix, which will look like this: first row, second row, and the third row. Okay, so now in order to find this element, we take the first row multiplied by the first column. Of course, we can just factor out 1 over 5 and then find the first element. This is 1 times 3, 1 times 3 plus 0 times 3 and plus C. Okay, so I hope we need more space here. Let me find a little bit of space, starting over somewhere here. Now I have a fifth of, I want this element. This is what I'm going to do: 1 times 3 plus 0 times 3, 0 times 3, then 2 times 1, 2 times 1. So first element. Next element, so still the first row and the second column. So I have 1 times 2 times 2, 0 times 2, 0 times 2 plus 2 times negative 1. Okay, so now if I want to find this element, I have to take first row, then next the third column. So I will have 1 times 2, 1 times 2 plus 0 times negative 3, 0 times negative 3, and last that is least. So gonna have 2 times negative 1, 2 times negative 1. So this is the matrix that I will have. Okay, now second row now. Let us work out second row. So for second row, here, to find this element, so I'm going to find to make scalar multiplication of this one with the first row to get this element. So I'm gonna have 0 times 3 plus 1 times 3 plus negative 3 times 1. Okay, next 0 times 1. No, this second row, second column, 0 times 2 plus 1 times 2 plus negative 3 times negative 1. So this component, this is what I found. Now last will be 0 times 2 plus now 1 times negative 3 plus now negative 3 times negative 1, negative 3 times negative 1. Okay, now I'm going to have the third row, starting with first element in the third row. Going to have this, going to be this line times now the first column first. So I'm going to have 1 times 3 plus now negative 1 times 3 now plus 0 times 1. Now next again 1 times 2 plus negative 1 times 2 plus 0 times negative 1. 0 times negative 1. Next, so third column, first row, third column, scale up all that. 1, negative 1. Sorry, here it is times 2 plus negative 1 times negative 3 plus 0 times negative 1. Okay, this is the matrix that I want to find. Okay, so now here I'm gonna have a fifth of now. Let us see what I will have. This will be 3 plus 0 plus 2. This element will be 2 plus 0 minus 2. This is 2 plus 0 plus 2. And what I'm having here, so attention, this is negative 2. 2 times negative 1, it is equal to negative 2. Okay, so now next, this is 0 plus 3 minus 3. This is 0 plus 2, negative plus 3. Okay, this is 0 minus 3 now plus positive plus 3. Okay, now next, this element is 3 minus 3 plus 0. 3 minus 3 plus 0. So this is 2 minus 2 plus 0. So this is 2 plus 3 now plus 0. And what I get is matrix. Now this is 5, then 0, then 0. Second row, 0 and 5 and 0. And here you have 0, here you have 0, 2 minus 2 is 0, then I have 2 plus 3 plus 0 is 5. And now scalar multiplication at each element. So I'm gonna have matrix 1 0 0 0 1 0 0 0 1. Now this is the product A times B. So now what is the size? Size of this matrix is 3 by 3. Order, that is the size, what we can call size. And order is order 3 matrix. This is order 3. Order 3. And this is the product A times B. Okay, number B. So question B. Here, the question is describe the entries of the product. So the entries of this product, let me use a color marker pen. So this is 1 0 0 0 1 0 0 0 1. Okay, it is clear that all entries are zeros except on the main diagonal. This is the main diagonal. Main diagonal, which is made up of 1 1 1. This is the 1 1 1 element of the diagonal. Other elements are just a 0. Okay, that is B. Now some question C. So in order to answer question C, so let me find the space over here. So now A and B is okay. We have just calculated. Now we would like to move to some question C. So before moving on, so some question A, we have already calculated the product A times B is equal to 1 0 0 0 1 0 0 0 1. So because diagonal elements are only elements which are non-zero, this matrix is called diagonal matrix with element 1 1 1. It can be shortened just to recognize that every other element has zeros, and so we have only main diagonal element are just one. This is the question 2. This is the diagonal matrix. The diagonal matrix. So question C now. Let's move to some Question C. Now, such a matrix is identity matrix. So actually, when all diagonal elements are just 1, this is called identity matrix. And identity matrix most of the time is written as I, just to say that it is identity matrix. And most of the time it is indexed with the order n. In this case, order is 3, so n equal to 3. So it is written as I3 to specify that to specify the order. When we don't need to specify order, we can just write I to say that only diagonal elements are non-zero and are equal to 1. So this matrix, when we don't want to specify the order, so we don't need to put it. But as order is for some importance, so you can just put this one like I3 in this case. Okay, now we call it identity. Identity. It is called identity matrix. Now, so this question is asking about among those matrices given in 1, 2, 3, 4, and 5, which one are identity matrices? So, I, the first one, let us start by 1, 1, 1, 1. This is a 2 by 2 matrix of order 2, but non-diagonal are not 0. So diagonal elements are okay, are 1, but there are non-diagonal elements are non-zero. This is not identity matrix. So we have 1. Okay, so I think that this is a special matrix. It has just it is a scalar matrix. It is just a scalar matrix, but with the order 1. It is a 1 by 1. 1 by 1. As its only coefficient is 1, we can call it identity matrix of order 1. 1 by 1 identity matrix as a special, very special case. Because 1 by 1 matrices are just scalars. So now number 3 here. So we have 1, 0, 0, 1. So now, as you can see, main diagonal are also 1, others are zeros. This is exactly identity matrix of order 2. This is identity matrix, a 2 by 2 identity, a 2 by 2 identity matrix. This is exactly a good 2 by 2. So identity matrix number 4. We have 0, 1, 1, 0. So here we have, so diagonal element are 0 and the non-diagonal element, this is not main diagonal, so 1, but this is not a diagonal matrix. This is not a identity an identity matrix. So this is the further studies can show that this is a reflection matrix. So now number 5, we have 1 0 0 1 1 0. This is a 3 by 2 matrix. So it could be a identity matrix if it were square, or if it were a square matrix. This is not a square matrix. It is a rectangular matrix, a 2 by 2, 3 by 2 matrix, which means that it cannot be an identity matrix, and it cannot be an identity matrix. It's not an identity matrix. So this is it is just answer for number 5. Okay, so now as what can we say now for sub-question D? Okay, for sub-question D, this is a very important question. It has talk about it here. So sub-question D. So matrix B. So that one we had before. So it is 1/5. It was 1/5. It is even it is clear here. It is 1/5, 3, 3, 1, and 2, 2, -1, and 2, -3, -1, 2, -3, -1. So it is inverse of the given matrix, the one we had before. Okay. So now, when do we say that two matrices are inverse of each other? When do we say that matrix is inverse of matrix B? So a matrix A will be inverse of matrix B. Here we can say that when a matrix is inverse of one, that one is also inverse of the other. So in that case, you have to get identity matrix. And also, B times A is also identity matrix, meaning that the product here, they commute, A and B may commute, and they give this special scalar matrix, which is a diagonal matrix where all elements, non-zero elements, are just 1. So this is how we can answer sub-question D. And this means that, this identity means that B is the inverse of A, and A is the inverse of B in this case. So from this identity, one of them, either the first or the second. So from one of these two identities, it can allow us to calculate the inverse. How we can calculate inverse of the to obtain matrix B. Okay, and this will be the inactivity activity, application activity 1 to 4. After this learning activity, this will be in our next video. Okay, now this is the end of this video. Thank you very much.